Let me start with the trivial operation, that is identity. Before that, what is the convention? What is the basis of the coordinate system? What is my assumption or consideration about coordinate system? I make it clear. A three-dimensional imagine when I do, at that time I want to consider x-axis towards left, right, y-axis towards you and towards me, z-axis up and down. Now question arises, what is the positive direction? See, such system will be there. It is our x-axis, positive direction of x-axis. It is y, positive direction of y. Upside thumb represents positive direction of z-axis. But when I perform the rotation, then we consider majoritically z as a principal axis. So through principal axis, when we'll do rotation, at that time the z-axis I'll consider as a rotation axis. So rotation will be in the xy plane. So for that it will be easy to imagine in this way. It is a positive direction of x, positive direction of y. It is a first quadrant. How and where will be the second quadrant? Second quadrant will be here. Negative direction of x, positive direction of y. Where will be the third quadrant? Third quadrant will be here. Negative direction of x and negative direction of y. Where will the fourth quadrant? Negative direction of y and positive direction of x. It is our fourth quadrant. So rotation will be in this direction. So from your point of view, it will be anti-clockwise direction. Let us start with the identity. If I consider in three coordinate system, any point here somewhere in this xyz coordinate, suppose here is a point, and on this point let me perform identity operation. After identity operation, what will happen? This point will change the position. In case if it changes the position by any means, again it will come to that position. That's our identity, restoring its identity, restoring the identity. Suppose if I perform reflection operation, reflection, double reflection, then identity. So ultimately point 2 will not change its position. If I consider its coordinate, say x, y, z, after identity operation, coordinate will remain x, y, z. How can I represent that mathematically? Identity as operation, our coordinate x, y, z, result is x, y, z. These are all matrices. I want to establish matrix for identity. So it is our consideration. I represented it mathematically. It seems to be the very simple, but lot of meaning is there in that. We can derive the matrix for the identity. See now the derivation. That x, y, z I can represent in other way mathematically. How can I represent that? 1x plus 0y plus 0z. And the second term 0x plus 1y plus 0z, and third term 0x plus 0y plus 1z. This representation is with two different matrices. How? See here. In the next step, given one matrix, 3 by 3 matrix, only coefficients of the previous equations are represented. What are the coefficients? 1 0 0 0 1 0 0 0 1, and right side matrix is a column matrix, only coordinates are represented, x, y, z. In other way, if you multiply first 3 by 3 matrix by second column matrix, you will get the result. What is the result? 1x plus 0y plus 0z, and second 0x plus 1y plus 0z, and third 0x plus 0y plus 1z. The result whatever you got there, that is identity. How? See the left side. Left side is E in column matrix x, y, z. Right side one matrix is there, 1 0 0 0 1 0 0 0 1, and x, y, z. X, y, z and x, y, z will get cancel, and E is equal to, E is a name for that matrix. E is an operation, and matrix for that operation is 1 0 0 0 1 0 0 0 1. It is the understanding about the matrix of the identity. Whenever in future we will use the mathematical term, mathematical matrix representation, we will use this as a term. And we were knowing for identity, we were using the same matrix. Now only what we did, we derived that. Let me know the procedure for that. So with simple, basic, trivial operation I started. So is the derivation for the matrix for identity clear? Likewise, we can derive the matrix for other operations. Here, what is the character for that matrix? Character is equal to summation of diagonal elements, and that character is equal to 1 plus 1 plus 1, 3. It is 3 characters. So how can represent? Character chi is equal to 3. And one more term I told to you before in terms of matrices, in the topic matrices, basics of matrices. Character of identity is equal to dimension. Keep in mind, we are using it repeatedly later on. I repeat, character of identity is equal to dimension. In the similar way, let us find matrix for rotation by 180 degree, means C2 operation. That remains in water molecule, no? But C2 operation, hydrogen 2 from your point of view, left side will come to right side, and right side hydrogen will come to left side. We are talking about now only one point. Let us derive that. So for that, I consider now in this 3 coordinate system one point. It is x, y, z point. All are positive. X is positive, y is positive, z is positive. After 180 degree rotation, see here, I am rotating now the molecule. I am rotating this point. This is a vector. You can consider one vector, radial vector, and that I am rotating. 90 degree rotation and 180 degree rotation. So after 180 degree rotation, the point which was here in the first quadrant will come in the third quadrant in XY system projection. If I have to do, means this point will come to this position. Now in this position, how are the coordinates? One by one let us discuss. What about x coordinate? Here x coordinate is positive, x coordinate is negative. So what is the coordinate of this point? X coordinate, positive or negative? It will be negative. What about the y coordinate? Y coordinate is positive towards you. Y coordinate towards me is negative. So what is the coordinate now for y? Negative. What about the z coordinate? Previously point was here, z coordinate was positive, now point is here, z coordinate remain positive. So z coordinate has not changed, z coordinate remain positive. Okay, positive, negative I discussed. What about the values? When it was with the x coordinate, after rotation become perfectly minus x. Try to work on that. After rotation become perfectly minus y, and after rotation it remains z. So now new coordinates are minus x, minus y, z. It is our understanding, but how can we represent in terms of matrices? C2 operation on x, y, z is equal to minus x, minus y, z. I want to represent that minus x, minus y, z in terms of simplified mathematical way. How? Minus 1 plus 0y plus 0z. Second representation 0x plus minus 1y plus 0z, and third representation 0x plus 0y plus 1z. I hope you will easily understand that. This representation encompasses 2 matrices. Coefficients we can collect together and we can write minus 1 0 0 0 minus 1 0 0 0 1 in a square bracket, in a matrix bracket. And next one, column matrix x, y, z. So if I simplify that multiplication of the 2 matrices, I will get the previous result. That's a desired result. If I simplify it further, C2 into x, y, z is equal to the matrix into x, y, z. X, y, z, x, y will get cancelled. So C2 is equal to minus 1 0 0 0 minus 1 0 0 0 1. That's a matrix for C2. It's our derivation. Again the imagination. Positive axis, positive axis, positive z axis. If I am considering this point x, y, z, I am considering y, z plane. Y, z plane means this plane, this mirror. So mirror is here and point is here. After reflection, where will that point go? Point will go behind the mirror. Up to mirror distance, the same distance will travel to other side. So again, x, y, z. After reflection, the point will come to this position. Now tell me, x coordinate will be positive or negative? After reflection will be negative. So it will become minus x. Y coordinate will be positive or negative? It will remain positive only. It was positive here, now also positive. Z coordinate, it was positive here, it's positive. So who has changed? X has changed. What is the plane? YZ plane. In YZ, x is not there. That is change. So what is the coordinates now? What are the coordinates? Minus x, y, z. Let me represent it mathematically. Sigma yz operation on x, y, z coordinate. Result is minus x, y, z. How can I represent minus x? Minus 1x plus 0y plus 0z. How can I represent the y? 0x plus 1y plus 0z. And what about z? 0x plus 0y plus 1z. Simplify it. I'll get the matrix sigma yz is equal to minus 1 0 0 0 1 0 0 0 1. And what is the character? Here also character is 1. Character of yz plane. Xz also was same. YZ also is same. Now left is xz plane. So xz plane means along x-axis and z. So what will the plane? This plane. So if any point is there towards your side, will come towards my side. Is it clear? So which coordinate will change? Here x coordinate, will it change? No. Y coordinate? Yes, y coordinate will become negative. Z coordinate will not change. So in that xz plane, who is not there? Xz. Y is not there. So y coordinate changes. So new coordinates will be x minus y z. Accordingly, the matrix will be, yes, you can derive that matrix. Matrix will be 1 0 0 0 minus 1 0 0 0 1. Again the character is 1.
Here are the all possible 4 operations for C2v point group and their matrices at a glance. Now what we have to do? Multiplication table we have studied, or qualities or characteristics of group we have studied, where closure, associativity, inverse, that we need to verify. Matrices has a boon that directly we can do the multiplication and can verify without pictorial presentation of the molecule. Let us see how far it is helpful in order to multiply one operation to the other or performing one operation followed by the other. What are the possible results? Are they incongruent? Are they in relation to our previous consideration? Here matrix for identity is 1 0 0 0 1 0 0 0 1, and for C2 minus 1 0 0 0 minus 1 0 0 0 1. For sigma xj, that's a molecular plane, 1 0 0 0 minus 1 0 0 0 1, and for non-molecular plane, a plane perpendicular to the molecule, minus 1 0 0 0 1 0 0 0 1. See here, all operations are represented upside. Let me consider now multiplication between C2 and sigma xz plane. By green color C2 matrix is represented, and by sky blue color sigma xz matrix is represented. See the multiplication between them. First row of the C2 matrix and first column of the sigma xz matrix will result 1 into minus 1 plus 0 into 0 plus 0 into 0. First row of the C2 matrix and second column of the sigma xz matrix, 0 into minus 1 plus minus 1 into 0 plus 0 into 0. First row of the C2 matrix and third column of the sigma xz matrix, 0 into minus 1 plus 0 into 0 plus 1 into 0. Likewise, we can perform the multiplication of second row of the C2 with respect to elements of sigma z, third row of the C2 and with respect to elements of the sigma z in order to generate all 9 elements of the matrix. What is the result? Result is minus 1 0 0 0 1 0 0 0 1. What that matrix says? It is which matrix? It is sigma yz matrix. It is a non-molecular plane. In conclusion, C2 into sigma xz is equal to sigma yz. So without knowing structure, we can establish the multiplication table. This is an alternative method to establish the multiplication table. You can attempt for all other combination. You will get the same results. That's the beauty of matrices. Therefore, we are studying the matrices. The important thing about the matrices. See. Here I am considering multiplication between two planes, sigma xz and sigma yz, by sky blue color sigma xz plane and by purple color sigma yz plane. Follow the multiplication rules. You will get result as green colored matrix. That's a minus 1 0 0 0 minus 1 0 0 0 1. Which matrix it is? C2. What is the meaning of that all? Sigma xz into sigma yz is equal to C2. That was also proved in our multiplication table. That's the inverse finding. Inverse of identity is identity only. You can work for that. How to find inverse? While finding inverse, whatever the original matrix is there, its rows are there, we have to convert to column. First row will be the first column of the inverse, second row will be the second column of the inverse, third row will be the third column of the inverse matrix. Let me do it forward the C2 operation. Original matrix is minus 1 0 0 0 minus 1 0 0 0 1. Let me take now first row minus 1 0 0 and arrange it in the column minus 1 0 0. Second row 0 minus 1 0, arrange it in the column 0 minus 1 0. Third row 0 0 1, arrange it in the column 0 0 1. What it is exactly same C2 matrix only. Therefore we say inverse of C2 is C2, but we work with matrices. It is an important achievement of the matrices. Easily we can find the inverse without pictorial consideration. Similarly, you can work for sigma xz and sigma yz planes. You will find sigma xz has an inverse in sigma xz and sigma yz has inverse in sigma yz. Here I used a color coding. Same color means matrix is same. So what inverse we were thinking, that also is followed here. Now homework for you. We understood now the inverse of identity is identity, for C2 is C2, for sigma xz is sigma xz, and for sigma yz is sigma yz. In case of C2v point group, what do you think? If we consider the all other point groups, the inverse of the operation, will it be always same as the original operation? If it is a yes, write in the comment box. If no, accordingly mention it in the comment box. I want to know your guess.